All right, everyone. Welcome to this week's presentation of the DBA Fundamentals Group. This week, we're talking about SQL Server versus Azure Cosmos DB with Hasan Savran. Today is April 22nd, 2025. So welcome to DBA Fundamentals. Today's presentation is brought to you by the three leaders of the DBA Fundamentals Group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you need to get a hold of us for any reason, to the right of our names is our X handles, so you can just grab us on there. Below that is the different kinds of social media you can hit us on. First up is Meetup, where probably most of you actually got to today's meeting and found it. Really simple. On there is all of our new presentations that are coming up, and what are probably our old ones as well. Below that is our actual website, dbafund.com, where we actually have all of our past presentations as well as all of our future presentations that we have scheduled. You can see all kinds of goodness. We have over 10 years of presentations you can look out for and watch. So be sure to find anything you like on there and watch it to your heart's content. Below that is our YouTube site, dbafundtube.com, where you can, as always, look at our past presentations. Be sure to like and subscribe on there just to make sure that you actually can get today's presentation when it actually becomes available, because you'll be one of the first to know at that point. So as always, be sure to like and subscribe. Below that is our X handle for our group, our Slack channel, and our LinkedIn group. Some of our upcoming conferences I want to point out is the Data Innovation Summit on May 7th and 8th. Then later on in June is the Databricks Data and AI Summit on June 9th through 12th. Be sure to turn off your video and mute yourself, just so we can all pay attention to Hasan and learn all kinds of goodness from that. And if you have any questions, be sure to type them into the chat so I can get them over to him as well. So with that, over to Hasan.
Great. Thank you, Steve. Thanks for everyone coming to see me and my presentation. Let me share my screen first and can go from there. I hope everybody can see the screen. Just going to do some adjustment here in my end quickly. All right. Thanks again. I'm going to actually talk with you about SQL Server versus Cosmos DB. So I guess the first thing I want to clear here is, these are great two products, and I'm not trying to do any kind of competition here. There are, places to use them, and I'm hoping, this presentation is going to help you to kind of pick the correct one in your upcoming projects. So the first one really I want to share is those numbers. You might already guess those numbers. Those are the ages of these products. So SQL Server is 30 years old and Cosmos DB hit 7-year-old. So Cosmos DB used to be actually brand new database, but it's kind of growing quickly, and there's some community out there right now using it. So it's a great option if you need any kind of like a NoSQL database. Cosmos DB is a great option for that. Before I start, I guess, share the other content here, let me talk about myself first. My name is Hasan Savran. I own the Savran Web Consulting. Mostly I do the Cosmos DB consulting. Rather than that, I have my own, I work for the full-time for the Progressive Insurance as a business intelligence manager. I'm located in Cleveland, and if you use already Cosmos DB, I'm the owner of the Cosmos DB SQL Studio. It's a VS Code extension. Many people, are don't want to query the Cosmos DB by using the browser. So if you're one of those, you can easily just download that VS Code extension and query it from your machine. Try to do something like SSMS, but it's pretty basic. But it's free. I just created that for community. So check it out. I'm always open to the feedback for that. Rather than that, I'm a Microsoft MVP for the data platform. I have my blog. I like to share about the databases, C#, and whatever I kind of know, I try to share it there. If you will have any questions about anything in here later, please, text. You can connect me from the LinkedIn or the X or Twitter, whatever you want to call it. I'm always there. I will be more than happy to kind of connect with you and answer any of your questions from there. So let's actually start from the slide 1 here. So before we go into many details, first, I guess let's try to compare what type of databases we are kind of talking here. So SQL Server is a centralized database. And whenever any of these, I guess the clients try to pull any data from the SQL Server, they don't really need to think about that much about where data is. That is really the database's problem to find data and just give it back to the client. So you can do all kind of things here. The sorting is pretty easy, finding the data, aggregating the data, all those actually handled by the centralized database, in this case, SQL Server. So access is easy, coordinating data is easy. So those are the advantages of central database, but it can really become the bottleneck quickly, especially if your queries are not in good quality. And also if those clients are trying to pull the data in the same time concurrently. So in those cases, SQL Server or any kind of centralized database can be a bottleneck easily. And also the scaling can be a challenge because of the cost and because of the other cases of the centralized database. You're going to hit at the end a CPU limit or the memory limit one day. So scaling can be an issue in these cases. For Azure Cosmos DB, things are a little bit different. So first of all, your data is not centralized anymore. So Cosmos DB is a distributed database. That means that your data is actually distributed all over the place. Of course, that depends how much data, I guess, you have in Cosmos DB. So in that case, for example, the clients are right now, if they need to pull any kind of data, well, the worst thing you can really do here is, send your query to all of these databases because you are going to use the resources, memory, CPU of each databases. And probably most of them are going to return no data anyway, but you're going to actually pay for that. So that is the main reason many people believe that Cosmos DB is an expensive database because, most of the time it's not, organized well by the developer and they not pick the right or correct partition key. And because of that, we end up with the cross partitions, and which costs the developer a lot of money at the end. So, for example, if I give you an example for that, let's say we have a very simple select statement like this. So we are looking for the product ID 10. Well, so as I said before, I'm going to cover that in a little bit about the partitions. But if the partition key you selected is not the product ID, well, that means that we have absolutely no idea where this data is. And we need to send this query to all database engines running out there and get the data from all of the database engines, which means that it's going to be very expensive. But if we pick the correct partition key, let's say that we pick the partition key as the product ID, which really what it really does is it just groups all the data together by, in this case, product ID. So if I know the product ID, that means that I don't need to send this query to many database engines. I can send only one, and it will cost much cheaper. It's almost like whenever you go to, like an event and you lose your car in the parking lot, you can just click the panic button and it will kind of start to, beep, and, you will figure out where it is easily. So really the partition key works just like that in the Cosmos DB. So since we are talking the partitioning, let's actually compare the partitioning first. In SQL Server, partitioning is really happening in the backend, and we usually kind of partition the data by usually datetime columns. So what really happens here is we end up with, like a huge table. Usually indexes can handle it, but if the table gets even bigger, the next step is usually partitioning. So we can actually make that huge table as smaller tables in the backend, and we kind of group the data usually by the date. So in that case, we just use the year. So the schema is going to be same in all of these small tables. And the best part is the user sees only one table when you might have 10, 20, 30 tables in the backend. We use the same database engine. And since we have fewer data to scan, well, then that means that the seek time is going to be much lower, and we are going to actually find the data much faster. So that's how the SQL Server, handles the partitioning. If we go and look at the Cosmos DB, Cosmos DB works a little bit different. The partitioning idea is still same, but I guess we don't really group the data by, on a file anymore. Actually, we group the files in more like in database engines or database servers. So if I give you an example, let's say we create a new restaurant, and our restaurant is very popular, everybody's coming in, and we hit the limit, right? We cannot take any more, customers because there's always reservations and it's always full. Well, we want to get, bigger and make it, even bigger. What we can do? Well, I guess you can make it bigger by maybe adding a different floor on top of that, or try to make it, bigger as a physical building. Well, in Cosmos DB, rather than doing that, what we actually do here is we are really franchising it. So we open out the restaurant in somewhere else. And so then, users has 2 different locations to go and get what they are looking for. So if you look at the backend, really in one physical partition, which is a replica set of Cosmos DB, we have 4 computers in it. We have 1 leader and 3 followers. So what really happens here is whenever a data change comes up, like update, delete, insert, anything like that, it goes into the leader, and leader syncs the data with the 3 followers here. One of these followers actually becomes a forwarder if we have this available in different regions. So, for example, if we have east and west, so the data, the right goes to the east. As soon as the data goes to the forwarder, forwarder actually is responsible to take that change and write it to the west side. So there are 2 numbers here that you should know by heart if you are using the Cosmos DB. The first one is 50 gig storage limit. So one physical partition can handle up to 50 gig storage limit. If you get close to the 50, that means that you are going to end up with another physical partition, another replica set, or another database server, whichever you like to, use. The second number is 10,000 requests per second. So that is really the horsepower of this physical partition. And depending on your web application, every time you run a query or any kind of operation in Cosmos DB, is going to cost you X number of request units. So the one physical partition can actually serve up to 10,000 request units per second. So if you have a really busy application and you need more than 10,000, you are going to end up with multiple database engines because of that. So the 2 numbers are the one which triggers new database servers for Cosmos DB. So in here, we don't really have any kind of control of anything. You cannot really change the limits. You cannot change this number. You cannot change the number of followers or leaders. So this is really just hard-coded in the Cosmos DB, and there's nothing really we can do in this level. What we can do here, the change is the logical partition. Logical partition is how you actually group the data. So you need to tell Cosmos DB which property or column should control the grouping all the data. So the first thing you need to know is that group of data cannot be larger than 20 gig storage. So hopefully you're not going to get close to that, but that is the limit of the logical partition. So, for example, if we are saving the orders, right? There's many ways you can, put a logical partition for it. You can do an order ID, which means that every time you're going to write an order, that's going to be a unique number. So all each tables are going to be really small, which is great. Cosmos DB actually likes that. Or you can go maybe pick another one, maybe customer ID. Then that means that all that data per customer is going to get located in the same location, which is really, I guess, a good one, because I don't think that's going to even get that larger. So you shouldn't be get close to 200 gig limit. What might be actually a bad idea, just like SQL Server, if you're going to pick, for example, a year, that will be a really a bad idea to actually use in Cosmos DB. Because if you think about it, this year you might sell 1,000 maybe orders. Next year you might sell 10,000, or it can even get bigger than that. That means that you might actually hit the 200 gig limit, or the partitions are not going to be really close to each other size-wise. So you want to pick something, I guess not like a common, like a date time, or maybe like a state or the city name. Those are really kind of like the bad ideas, because they are not really balanced to each other. So if you go, I guess, a little bit more details on this. So here, that's an example. Let's say we have a container named orders, and our partition key is customer ID. So each customer actually has its own kind of the data here. So as you can see, we have 4 partitions, and each of these blue boxes you see, really, they are just the customer. And the size really depends how many orders the customer, buys. So the first thing I guess I want to talk here about is, as you can see, each physical partition has a hash range. It starts from the 0 and it ends on the FF here. So by knowing what is the customer ID here, we can easily find the hash number, because whenever we try to, for example, insert data here, let's say we are going to insert a new data, and my customer ID is John1234. Azure Cosmos DB is going to do the first thing is the hash my partition key. So it's going to hash to John1234. By doing that, it's going to actually know where this partition key is going to be. So the hash number might be maybe in here between these 2 hashes. So that means that I'm going to actually take this data and send it right here, because the range of the hash is actually meeting here. So that's how we insert the data. It works exactly the same way when we try to select the data. So when we are selecting the data, let's say my customer ID is John1234. When I hash it, it's going to have the same exact hash number that I found, which was somewhere in here. That means that I'm going to take the select statement and send it here, rather than send it to each of them. And that's going to be much cheaper for me to actually have my customer ID available all the time. So that's really important. Whenever you create a partition key like this, you want to be sure that it's going to be always available when you use the select statement. So it will be the cheaper for you to run that query, rather than you send it to 4 places, and it's going to charge you maybe 5 request units for each. You're going to end up with 20 request units. If you have the partition key, it's going to cost you maybe only 5. So that is why the partitioning is pretty important in Cosmos DB. And I guess you really need to pay attention to that, because before you create the container, Cosmos DB is going to actually ask you what is the partition key for this. So before you have any data, it's going to ask you that question. So you really need to study your data and figure out what your partition key is going to be, because you cannot change that partition key after the container is started. You can, but it will be pain, because you need to move all the data with the different partition key container. So it will be pain. So if I were you, I will really pay attention before I start any kind of containers in the Cosmos DB. Be sure the customer ID is going to work in long run, and then you should not have any problems. Just don't think that I will change it later. That might not be a good idea for the Cosmos DB. All right, next one is query plan engine. So let's actually compare, I guess, the SQL Server to Cosmos DB with that. So let's say we have the simple query. we are looking the posts, I guess the table, and we are looking the parent ID 11. So whenever you take that and put it in the SSMS and click an execute button, what happens? Well, the first thing SQL Server is going to go and look at the parse and bind section, which is going to check your select statement, if everything is correct. Do we have all the tables in the SQL Server? Do we have all the columns in the SQL Server? Are we good to kind of, like move to the next step? So if that passes that, the next step is going to be the query optimization, which is probably the most complex part of the SQL Server. For that thing to work, well, SQL Server is going to go and look at your table. It's going to look at all the indexes it has. It has all of the statistics, size of the tables. And after that, it's going to start to create all kind of query plans, how it can actually get this data back from the database. Then it's going to go back and look at all these plans and find which query plan is the fastest by looking at the estimates and figuring out how much memory is going to need, how much I guess the CPU is going to need, how many rows are coming from which table. Then it's going to cache that plan so it can use it again. Then it's going to display you all the I guess the rows in SSMS. So that's how SQL Server works. When we compare this to Cosmos DB, well, in Cosmos DB, it's similar. At the end, it's a database, but there are some couple of like changes here. So that's the query for the Cosmos DB. We are still looking at the same posts container, which we call a C this time, and parent ID is 11. The parse and bind is there, but it's not going to be that much to check out there because no, SQL Server has a schema. Cosmos DB does not have a schema, so we don't really kind of check that much about the columns and other stuff here. But we are going to check if the select statement is correct. From here, the next step, which is very important for developers, is if your SDK, which is actually executing this query, is in 64-bit, that means that we can actually create this query plan locally without going to the Cosmos DB, which is going to actually save you one request, which is a lot because for every select statement, you're going to save one request to Cosmos DB. If it's 32-bit, then that means we have to make a request and actually create the query plan in Cosmos DB. When it comes to the query optimization, again, first thing, if we have to create the query plan, if it's 32-bit, that's what we have to do. Then the next thing it's going to check is, well, is partition keys available in our query? So we have the parent ID 11. If parent ID 11 or the parent ID is the partition key, we are great because we will know which database engine actually will have this data, and we will send this query to only one database engine. If it's not available, then things are going to get tricky. Let's say we have maybe 10 physical partitions. That means we are going to send this query to 10 different database engines. And depending on that, some of them might return data, some of them might not return data, and we need to wait that query to be run in 10 servers in this case. Then as soon as all the data comes back, all data is going to come back to our Azure Cosmos SDK. So if you really think about it, well, that is the only place the data gets centralized. So before the data comes to this SDK, you really cannot do any kind of aggregation. You cannot find the minimum, you cannot find the maximum, you cannot find the average because data is all over the place and it's not only in one database engine like the SQL Server. So that's why the SDK, wherever that SDK is running, you want to be sure that that SDK is going to have a good, resources, memory-wise, CPU-wise, because as you can see, SDK can get really busy here, depending on your queries. All right, next is the data models. So in SQL Server, you can save all type of data models. It's a relational database, but you can still save JSON, XML, and it has even the graph database engines. Also, they are adding the vectors on top of that. So everything is great, and SQL Server team is, really try to, integrate all the modern technologies to SQL Server every year. You see, new stuff coming up with every version, which is great. And also, you just need to know the T-SQL. And with T-SQL, you should be able to, master any of these data models if you like, which is great because you don't have to learn a whole totally new, I guess, language for it. But in the meantime, you're kind of limited by the T-SQL. So you might not be able to use some of the, for example, graph database kind of features, which is available in Gremlin in SQL Server, because at the end you are with the relational database. So in Cosmos DB, as you can see, we have different data models. NoSQL is the core API of Cosmos DB, and its language is very close to the T-SQL. So if you know the T-SQL, you should be able to master that probably in 2-3 weeks. You will have no problem querying the Cosmos DB if you are using the NoSQL API. Rather than a NoSQL API, there's MongoDB, Gremlin, Azure Table, Cassandra, and also the PostgreSQL available in Cosmos DB. And each of these data models are using their own native languages. So if you are, for example, MongoDB, you are going to query the MongoDB with the MQL. This makes Cosmos DB an easy place to migrate. So if you are using any of these items, for example, if you have a MongoDB already and you are tired of maintaining it, and you can easily move your data to Cosmos DB, and all of your applications should work because you are really not going to change a database language here. You are still going to use the MQL. In that case, all you really have to do is change your connection string from your current MongoDB to Cosmos DB, and you are set to go. So that will actually work with all of these data models for Cosmos DB. Next one is indexes. So SQL Server has all kind of indexes out there, and the most, I guess, the common ones is the clustered, non-clustered, filtered. And if you compare that to Cosmos DB, we have range and composite indexes, which is working pretty similar to each other. We have column store indexes in SQL Server for analytical queries, and Cosmos DB has analytical storage. It's the kind of same idea, the way that they save the data, column store and analytical storage in Cosmos DB. You can have the full text indexes in SQL Server. In Cosmos DB, they actually just bring the full text indexes. They are available. I think it's still in preview right now. But before that, we were using the Azure Cognitive Search if we had to do any kind of full text in Cosmos DB. Both products support the geospatial database or the data model, so we have indexes for that. So when it comes to do, I guess, handling the indexes, in SQL Server, usually when you create a table, if you don't have a primary key for it, that means you have no indexes in it. So you start really usually with 0, or if you have a primary key, you have 1 index. Most of all of the indexes are centralized with the database, and they're in the same location. And whenever you need to change something, you usually change. That change needs to happen like one by one, so you don't create any kind of locks or anything like that in the tables. In Cosmos DB, when you create a container, everything in that container is actually getting indexed, unlike SQL Server. So if you have, like, let's say you have 20 properties, 20 properties will be indexed, so you don't need to worry about what should get indexed, what shouldn't get indexed. That can be a problem though, because of that, you have a data file, you have an index file, where your index file can get larger than your data file because you are indexing everything. So you end up, probably exclude some of those indexes that you don't really need in Cosmos DB. Each physical partition has its own indexes. So if you have 10 database servers, that means if you need to reindex that, you have to reindex 10 servers. And because of that, if you have a change, if you need to exclude or include new indexes, you better do that together rather than do that one by one, because it can take a long time. Reindexes, well, I guess technically it's free, but what's really happening here is whenever you create a new container, you tell Cosmos DB how much request units you want from Cosmos DB per second. Let's say you say 1,000. And maybe your application is using 800, so you have like this 200 request units per second you don't really use. Well, when you do a reindexing, application, actually, the Cosmos DB is going to use that whatever you have left per second to complete the reindexing for your containers. So because of that, it might take sometimes long time, especially if you have a lot of time. I mean, if you have a lot of data, it might take a long time to reindex to be complete in Cosmos DB. So what you can do is you can maybe, scale up before the reindexes, and you can scale down when it's completed. So that's an option you can actually do for Cosmos DB. All right, next one is store procedures. Store procedures are very popular in SQL Server. You need to know T-SQL. They are read and write friendly, so you can do both operations with no problem. They give you better performance because it caches query plans for you. So it works much, better and faster. And also you can join tables. So they are not really specific to one table. They can work for, the different tables and databases, I guess, if you let it to. In Cosmos DB, it's totally different. Really, its store procedure name is same, but everything else is really different. But first of all, they are not in T-SQL. So you have to know JavaScript to be able to actually create a store procedure in Cosmos DB. You can read and write, but they are not really read-friendly. They are write-friendly. If I try to explain that why is, so if you remember the replica set I showed you, we have a leader and 3 followers. The store procedures will always get executed by the leader. They will not get executed by the followers. So they are write-friendly because leader is always, taking the write first. But if you are going to create a store procedure which reads data in Cosmos DB, you are really forcing leader to read data, which, leader is usually busy by doing other stuff. So it's really not a good practice to read data with store procedures in Cosmos DB. They are specific to one container, so you cannot really join different containers. So if you create a store procedure for orders container, all you can have access is really the orders container. You cannot do anything else to other containers. You can also implement transactions by using store procedures in Cosmos DB. Next one is triggers. Triggers can be useful depending what you do in SQL Server. Those are really special store procedures. There are different type of triggers depending on what operations is happening, and they get executed automatically in SQL Server. In Cosmos DB, there are special store procedures, which means you still need to know JavaScript, and there are only 2 types of triggers. First one is the pre-trigger, which get executed before it changes any data in the database, which is a great one if you need to validate anything before you change any kind of data. And the second one is the post-triggers, which actually you can execute it after the data change is completed. The biggest difference here, rather than, being the T-SQL and JavaScript, in Cosmos DB, you need to execute them manually. They are not going to get executed automatically like SQL Server, and you can do that only from the SDK of Cosmos DB. All right, next one is computed columns, which can be really useful. I use them every day in SQL Server. Those are the virtual columns. They can be real column if you actually, create an index on them. And these are available whenever you go and look at the SSMS, you look at the table. The structure, they are available out there. You can see they exist. And when you write select all, they become available on the results. And they are indexable. So those are the SQL Server. In Cosmos DB, they are virtual properties. They're not columns anymore, And when you write select all, they are not visible. So that's really, you need to know by heart the name of them. That's why sometimes, many people use the CP underscore the name of the, the computed column. So you have some kind of structure about it. You can go in SDK and portal, and you can see them there. But unfortunately, when you select all from a container, if there are 2 or 3 computed columns, they are not going to come up as a result like in SQL Server. So you really need to know them, that they exist. They are indexable, just like SQL Server, which can actually make your queries cheaper. Everything is case sensitive in Cosmos DB. So I see many times that people uses lower or upper functions in your where clause. So, whatever you're passing, well, the case sensitive, I guess you can handle it like that. So you can easily create a computed column, and you can make a lower or upper, and you can only, like when you write in the where filter, you can use the computed column name rather than using the function here. So in that case, it should make your request much cheaper because you don't have to do a table scan because you are using a function. So they can be really useful and make your queries much cheaper if you use them, correctly. So lower, upper are really common ways. And if you are doing any kind of maybe calculating the number of days between 2 date times, you can really use those. So those are the some of the common ways I see many people use the computed columns in Cosmos DB. Next one is pricing. Well, when it comes to pricing, we can talk about probably the whole hour for SQL Server. There's too many different ways, I guess, to pay the SQL Server. So those are just some examples here. Some of them is from the Azure, some of them is from the on-prem, and even pay-as-you-go rate is available. So depending, what you need from SQL Server, there are different ways to, I guess, pay your bill. In Cosmos DB, it's much more simple than that. So the first of all, the storage and the CPU is separated. So depending how much storage you need, you can easily figure out how much it's going to cost you. For transactional environment, it's going to cost you 25 cents per month for 1 gig. And if you need analytical, that's going to cost you much cheaper than that. So when it comes to the CPU, you have 2, I guess, rates. If you need, if you have an application in production and there's always some kind of traffic on it, you might want to go with the threshold, and it's gonna cost you $6 per month for each 100 request units you are gonna actually ask per second for Cosmos DB. The minimum number Cosmos DB will give you is 400. So you are really looking here somewhere $25 to $30. For a single region for Cosmos DB. If you have an application and you don't really need a constant power from the Cosmos DB, you might have an Azure function, or whenever you run a function, it just needs a database a couple of times a day. You can easily go with the serverless. Serverless is much cheaper. So for each 1 million request units, it's going to cost you 28 cents. So whenever you run it, Cosmos DB will just subtract whatever you use from the number you buy for the serverless. It can really make things really cheap, especially if you don't, if you have an application doesn't need all the time, the, I guess, available database. Next one is views. Views are very useful in SQL Server. Those are the virtual tables. You define them by a query, and you can index them and you can materialize them, and they make the user's life much simple because they don't need to know all that joins and data models. You can just give them the view, and that's all they need. It makes things very nice for the users. For Cosmos DB, we really don't have that view concept in NoSQL databases, but there are some ways that you can actually create materialized views. And we can use the change feed feature of Cosmos DB for that. So if I actually give you an example for that, for example, let's say we have a container named orders, and our partition key is customer ID, and looks like I have 2, 4, 6 physical partitions here. So everything is great if I have the customer ID. If I don't have the customer ID, for example, I am looking, well, give me all the orders for a specific product, which is a valid query. Well, when I run that, since I don't have the customer ID here anymore, I need to take this query and run it in every database engine I have. And each of them is going to cost X number of request units. So in that case, as you can see, this cost me 49 request units just to run one query. Well, if you are in this situation is going to get even worse because you know that the storage is going to get larger or your application is going to get busier. Well, hopefully it's going to get busier. If that's the case, that means you're going to have, more database engines are going to be available. So this might cost 49 today. Well, next year you might be looking much higher request units here because you're going to have more servers coming. So how do we fix this problem? Maybe customer ID is already working fine for 80% of the queries. That 20%, we are having this situation here. Well, you can easily create a materialized view to actually fix this problem. So to do that, in here we are really spending money, I guess. So in here, to create the change feed, all we have to do here is we just create another container. So in my case, I am creating a new one named orders_product. And I am saying my partition key is going to be product ID. So I already have the orders container and change feed is already working on it. All I have to do is really create a Azure function, or you can create a manual kind of application to get the list of what is really changing in orders. It's almost like the change feed in the SQL Server, and this will kind of find all whatever is changing in orders, and it will trigger the Azure function when change happens. From here, you can really do anything. In my case, I'm going to run the Azure function, and I'm going to put this whatever is changed here to the orders product. So the containers will have the same exact data. So I guess the cost for this is whenever you try to insert data, that's going to actually charge you. And also the storage is going to get double, but you might actually save much more because depending what query you have, now you have two locations to get your data. If you have the customer ID, you go to orders. If you have the product ID, you go to orders product to make things, much smoother, cheaper, and faster. So you might say that, well, I don't know Azure functions, I don't know Python, I don't know C#, what am I going to do? Well, for that, actually, Cosmos DB created a new way to create a materialized view, which is, I believe, is in public preview right now. You can go to the features and you will see the materialized view. You can just turn this on here. Then it will give you a UI and you can just select what properties you want to actually move to. And you can create this UI rather than try to create any kind of Azure functions or kind of do any kind of coding. You can actually do that on the Azure portal if you like. So in this case, now if I'm going to run the same exact query, now I'm looking, well, I have the product ID rather than orders. I'm going to actually go and run this in the orders_product. So because the product ID is the partition key, rather than hitting to all the database engines here, I'm going to go and get it from one place, which is, I'm going to save a lot. As you can see, my original cost was 49. Now the current is going to be 8. So that's going to actually save you a lot of CPU time, a lot of, cost, really. And that should make the things much faster. At the end, in cloud, storage is the cheapest. And if the duplicating data is the way to kind of make things cheaper, that's really how we do it in the NoSQL environment. I know that's a no-no in relational databases, but duplicating data in this case is really helping us to fix this kind of problems. All right, next is performance tuning. So really, that's really a whole job for in SQL Server. So if we try to, put them in a list, whenever you are selecting a data from SQL Server, just select only what you need. Just don't use the select all the time. That will actually help. Look at for missing indexes in SQL Server. If any indexes, missing, that can really give you a quick fix for many queries. If you are using any kind of query hints, well, be careful with them, because at the end, SQL Server is going to know how to get that data better than any of us. Putting, query hints out there might actually might maybe fix them in short term, but in long term, you might be still in trouble with that. Look for any kind of parameter sniffing in SQL Server, especially if you're using the store procedures. Those might be sometimes the problems when it comes to the performance. You're going to use the execution plans in SQL Server to kind of figure out what's really happening in the backend, so you can do something about the problem. And if the indexes cannot really handle the large tables, then the next step probably you are going to do is the partitioning in SQL Server. In Cosmos DB, well, the first one applies perfectly. You want to select only what you need from the Cosmos DB. You can use the indexing metrics which Cosmos DB offers. You can turn it on, and it will actually suggest you if you are using any kind of, if you are losing any kind of indexes, it can kind of suggest you that. So in Cosmos DB, there are two ways to get data. One of them is to query the data, and other one is the point read the data. So the point read can actually only get one object. It cannot be, like a list of objects. So you have to pass the partition key, and also you have to pass the ID of the JSON object. So if you have those two numbers, or the two, the properties available, rather than, running a query, you can actually run a point read operation, which will be much cheaper than query. For example, let's say your data model is 1 kilobyte, right? So if you are trying to query that data with the partition ID and the ID of the document, the minimum is going to cost you usually between 2.5 to 3 request units per second. But if you will do by the point read, that's going to cost you only 1 request units. So it's really important to be, whenever, if you have, for example, a grid on the screen and you're going to click on a row, you want to be sure that, the partition key and the ID of that row is available. So you can actually go and run a point read rather than a query to get the, the data under that row. You want to have smaller number of containers. In SQL Server, you can have a lot of tables, you normalize things, and everything works great. In Cosmos DB, that's not the way, because usually you want to kind of put those tables together, and since we don't have a schema, you cannot have a joins. So you want to know exactly what your user, your client is going to get from you, so you can create a JSON object exactly like what they need from you. You can use the materialized views that I just showed you with the change feed if you have many cross-partition queries. In Cosmos DB, there's a TTL options, which is time to leave. And if you have any kind of retention policy, for example, 2 years after that, you don't care about the data, you can delete from the Cosmos DB. You can make the TTL 2 years, and Cosmos DB will delete that for you for free when that time actually comes. Also, you have the execution metrics. I guess you cannot really compare the execution plan. Execution plans, all kind of information. But if you want to really see what's happening in the backend, most of the data is going to come from really the person. It's going to show you how many seconds it took to complete items. It might help you, but they are not really like execution plans of SQL Server. Next is, null and undefined, how the database actually handles that. So in SQL Server, the null is really neither an empty string or a zero value. So you have the is null and is not null to kind of handle them in many cases. For example, many people make those, mistakes when you do, for example, using the count. The SQL Server will not count the null rows, or when you do the average, it will not include the null rows. So whatever number you are expecting might not be correct if you are not handling the null values in SQL Server. But at the end, you get some kind of value when you run it. In Cosmos DB, things get a little bit more uglier than that. So in Cosmos DB, first of all, we have is null or is defined. So at the end, we don't have a schema. So you might want to check if you are, for example, using the average of ages, you want to be sure that each document is going to actually have the age property. So that's why we have the is defined, since there's no schema in Cosmos DB. But if you will have any kind of null values, let's say you have 100,000 users, right? And you want to kind of get average of the age of the users. But one of these people do not have age. It's a null value. If that's the case, then Cosmos DB is going to actually throw an error. It's not going to try to give you any numbers like the SQL Server. So any kind of aggregation, any kind of mathematical expression, if it finds null, you will end up with an error in Cosmos DB. Because of that, if you have any kind of null values, just don't save them in Cosmos DB, because at the end, see, you don't have a schema. So if the age is null, well, don't keep the age property in Cosmos DB for that record. So you will not have, I guess, a problem like that. That's the easiest way to kind of fix a problem like this. And also, if you don't keep the null, then that means you're going to save it to storage because, well, you don't need the property, you don't need the value. So that's going to actually, help you with the storage in Cosmos DB. Data modeling, that's a whole different, like a topic. And again, we can talk probably 1 hour. But in SQL Server, really, it's a relational database. You can join any table to, any table. And, it's really going to a sandwich, I guess, the restaurant. Every time the user can, or the client can create all kind of sandwiches, whatever they really need dynamically. So because of that, there's a constant pressure on the query optimizer because, really, you never know what query is going to look like the next time when somebody comes in. But that's, in the meantime, that's what makes the SQL Server, I guess, good, because you can dynamically change the data models and, we can put indexes on it and try to, keep things fast and flexible, which is great. Cosmos DB doesn't work like that at all. In Cosmos DB, first of all, there's no relations, so there's no joins. You cannot join anything. So there's no schema. So you better know, I guess, what your client is going to ask, right? So if, for example, if you have a product page in your company, you are going to know exactly what that product page is going to ask from the database. So put all that information that one page is going to ask in one JSON object. So all you'll need to pass is a product ID, and Cosmos DB will give you one JSON object that everything you need for that page to get rendered. So, in other case, this, I guess, if you compare to Cosmos, the SQL Server, you better know the client. If your client is, vegetarian, don't try to create a data model and put all kind of meats in it, because, you're going to have a problem. It's going to cost you much more to kind of filter those things out, and just know, I guess, what your customer wants in not just Cosmos DB, but any kind of NoSQL databases. So everybody came here to kind of, I guess, for the same question, which one should I use, right? So in this question was pretty easy in earlier years because, well, if you need a relational database, you go with SQL Server. If you don't need, if you need a non-relational, you go with the Cosmos DB. But that's really not the case anymore, because you can save JSON, XML in SQL Server. So you can really save non-relational models in SQL Server, depending, I guess, what you need. So if your application is like an enterprise application, it's a smaller application, SQL Server should be able to handle any of those JSON objects, if you don't have like a big user base. Also, we have graph database tables. So you can make things much faster with the memory tables. So those are great options with SQL Server. I guess it really depends how big your application is going to be. Because at the end, the scaling can be a problem with SQL Server because you have to go scale up with the SQL Server. Another great option of SQL Server is available on-prem, so you don't have to be on cloud, and you won't have to kind of worry about all that latencies between your, the on-prem servers and the cloud. And when it comes to aggregation, SQL Server is the king. There's all kind of things you can do with SQL Server. You can use it as a transactional database or a data warehouse. You can use both because of, it has great aggregation functions. Cosmos DB, we used to say, well, except for non-relational database, but now actually it supports a PostgreSQL. So that makes things a little bit more, I guess, gray now. So if you have an application already in cloud, it kind of makes sense to kind of use something in cloud. So Cosmos DB is a great option for that because it's born in clouds and it can connect many things very quickly and easily in Azure. It has multiple consistency levels. So depending on your, SQL, in SQL Server, you usually have like eventual or the strong. Cosmos DB actually has 5. So depending what you are trying to do, it can give you more options with different consistency levels. Also, it has a global distribution with multi-region, right? So if you really have one, busy application available in different countries, Cosmos DB is really a good option for that. And that's where it really starts for big companies. So again, as I said before, I hope this session kind of help you to figure out which way to go when a new, I guess, the project comes to you. And thank you for listening to me today. Again, you can reach me from any of these social media. I'm mostly available all the time. Please try my Cosmos DB SQL Studio. If you have time, it's free. All you need is VS Code. You can just go to the extension, and if you search for Cosmos DB SQL Studio, you will see it. And I was actually work on this book. I review it, and it's a great one, especially if you want to pass that Cosmos DB certification test. That's a great book to have. And well, yeah, I hope everyone learned something new today. And if you have any questions, I'll be more than happy to answer them. Thank you.
Well, thank you, Hasan. I know I've learned a fair amount of things through this one. Like always, that's why we enjoy inviting different people around to see what kind of goodness there is. So next week, while everyone's thinking of questions to ask they haven't had answered during this thing, next week we're having Michael Oshimsky talk about AI-driven integration of enterprise data. That is on April 29th. Then in June, on the 17th, we just announced today that we're having Sergey Prakama talk about securing the cloud, Snowflake's approach to data governance and privacy. So that will be a fun topic on Snowflake. I know Serbi's really good presenter on that. She's talked about Snowflake a few times before. So please be sure to join us when she comes back in June on that one. So it looks like no one's had any questions, or at least they don't want to ask through the year. So Hasan, I do appreciate everything you've done here. This has been great.
Thank you. Thank you for having me.
Yeah, my pleasure. All right. So with that, thank you all very much. Have a great day, and we will talk to y'all next week.
Yep. Take care.
You too.
Bye.
Bye.